Alright, so in this video I'm hoping that I can show you guys how to use the graphing calculator to find the area of a region. And in particular what we're going to need to do is we're going to need to use the calculator to figure out what the points of intersection were. In the previous video we would have understood that for a question like this one, where it says, find the area between e to the x and 6 cosine x, we're going to need to find out what the left bound of integration and what the right bound of integration are. So over on the left, I've got our trusty TI-84 graphing calculator, or the TI Inspire with the 84 faceplate, and I'm going to walk through those steps. So clearly the first step has got to be putting these functions into the calculator. So as you guys should be well aware, you hit the y equals button. When you hit that, it brings up your y equals screen. We can now type in e to the x. So I'll go second. ln brings up e to the x. We type in our x. Down arrow lets us go to y2, and then we can put in 6 cosine x. Great, we've got these things in there. And I just realized something we should really do is we should always check to make sure that we're in Radian mode. So I'm going to quit out of this, go back to mode, and sure enough, our calculator is in awesome mode, which is Radian mode, so we're good to go. So we'll quit back out of this. This, by the way, right here is going to keep track of like all of the keystrokes that I've hit. So if you need to try and follow back to see what I hit, that'll show you that. Seems kind of, it even keeps track of when you hit the down button, which is kind of funny, but right on, it does what it does. So great, we put those things into y equals, we're now ready to graph them, so we hit graph, and it comes back and shows us that picture. On the one hand it looks different, on the other hand it's just because this one has been more zoomed in than this one has, and that's not a big deal. So to find these points of intersection, what we're going to use is we're going to use this little calculate menu, which is right above trace. So I'm going to go second, trace to bring up that calculate menu. Then I'm going to go down and I'm going to choose option 5, which is the intersect option, right? So we hit enter for that one. Now it's going to come up and ask us 3 questions, and they're sort of funny questions. The first one says, what is the first curve? And you'll notice the cursor is sort of blinking on this first curve, which was, interestingly enough, y1. What you're going to do here is you're just going to hit enter. You're going to say, yep, that was my first curve. Sounds good. Then it's going to say, okay, what's the second curve? And notice it's going to jump over to y2. As long as you only put in 2 functions at a time, you can just hit enter once on the first one, hit enter again on the second one to choose the second one. Then it comes up and says, well, what's your guess? What do you think it is? And you may be thinking, like, I have no idea what it is. That's what I'm asking the calculator for. Really what it wants is it just wants you to get the cursor close to where it is, right? So you can just use the, the side arrows to sort of move backward here and just get it nearby, near the point of intersection. You hit enter, and it'll think for a little bit, and then come back and tell you, hey, that first point of intersection right there is negative 1.534, right? Now the issue is, my worry is that you guys are going to on your paper write down, oh, okay, it's negative 1.534. Or maybe if you're being precise, you'll write down the 875 as well. What I want is I want us to store that value, right? So in case you've forgotten how to store these things, the way that you store is, this is currently stored in x. So it says x equals that. So we can quit out of this graph, and at the home screen hit x, store a, and it will store that entire value to a. Now the way I recommend you do this on your paper, so when you're over here, doing your homework, you can write, okay, a is negative 1.534,874,825. And the good news is from this point forward in the homework, you don't even have to reference this number anymore. You can just use an a, right? That also reminds you that on your calculator, you stored this number as a. And so as long as you don't store anything else there, that number will stay as a. So great, we got a. Let's go back to our graph and find the other point of intersection. It should be the same steps, so I'd actually recommend you pause the video, and if you've got a calculator, try it on your own to find that point of intersection. So here we go. I'll go second calc. I'm just going to hit 5 to jump right down to the intersect option. I'll hit enter for first curve, enter for second curve. For the guess, I could either use the arrow keys to scroll over there, or, I can tell that value is kind of close to 1, so I'm just going to type in 1. And it'll say, oh, you want to guess 1? Sounds good. Enter. comes back and says, yep, that point of intersection is right there. It happened at 1.065, blah, blah, blah. So again, I'm going to quit back to the home screen, X store. This time I'll store it to B. And so on my paper, I can write down, yep, I took B, and that was 1.065758888. On the AP exam, all they want is 3 numbers after the decimal place anyway. So to be honest, it's actually okay to just write down the first 3 numbers after the decimal place. Whether you truncate or round doesn't matter. And what's valuable is your calculator knows more than just those decimals anyway. So when we go to get our final answer, we're going to get a nice, precise answer out of it. So great, I've got my A value, my B value. Now I want to actually set up this integral, right? So I'm going to do the integral from A on the bottom to B on the top of what? Well, my top function here was 6 cosine x minus the bottom function was e to the x dx. So, like on the AP exam, on the homework, are you allowed to write A and B here? Absolutely, so long as you've done this. If you wrote those things down, you're good, right? So, as far as I'm concerned, this is how you show your work for calculator problems. So now how do we actually do that calculation on... How do we actually do that on the graphing calculator? Well, hopefully you remember that. On the graphing calculator, we do math, and if you either scroll all the way down, or because it's sort of obnoxious on mine, okay, I just hit down too many times. Hit 9, we want to do the integral. And at this point here, our lower bound was A, so we type in A. Sideways key lets us get to the next one. Alpha B up here. Now here, what am I taking the integral of? You have options. You can either write 6 cosine x minus e to the x, or you can remember from your y equals, remember those functions were y2 and y1. So what you can do back here at the home screen is you can basically just type in y2 and y1. The only trick is where do we get those y2 and y1 from? There are 2 places depending on the version of your calculator, so I'll show you where they are. If your calculator has been updated, it's really easy. You hit the alpha button and you hit that same calc button we've been using, and it'll come up and give you a list of all of the y functions. So I'll just go down and pick y2 minus. Now I need to do y1. I could do the alpha F4 trick, but in case some people don't have the updated calculators, I'll show you the other place you can get it. It's really kind of annoying. You hit the vars button, and you hit the sideways button to get to y vars. Enter for function, enter for y1, and it'll paste it back there. Last thing we have to do is throw an x in here, enter, and yay, we get our value, right? So this integral, this thing I worked out, is 8.559, or we could do 8.560 if you decided you wanted to round up. Either one of these values would be acceptable on a test or on the AP exam. I had another example where I was going to go through how we do the same thing for finding x-intercepts, and I think I'll do that really quickly, but I don't know that I'll finish the problem. We'll see what happens. I'm going to clear out all of this stuff, and I'm going to clear the key press history so we have a fresh start on this thing. And I'll probably run through this one a little bit more quickly. So in this one, I'm going to graph x cubed minus 4x. Oh, bummer. Let's try that again. X cubed, arrow key, minus 4x plus 2. So we graph this guy. Man, it looks roughly like I think I have there. Now I need to go through and I need to find these. Now notice they're not points of intersection. These are actually x-intercepts, or zeros. So the same thing, I'm going to go into the calculate menu. And notice the second thing there is 0, so I'll pick 0. This time it's going to ask me different questions. First it's going to ask for a left bound. So you move the cursor to the left of the one you're looking for. So that's, you know, if this is the intercept, this is to the left of it. Enter. For a right bound, you sort of scroll over so you're to the right of it. Enter. And then same thing as before. You go with a guess, you go kind of in between. So that first 0 right there is going to be the first of these intersection points. So I'm going to say that A is negative 2.214. In a minute here I'll find out what B and what C are. But before I do that, we quit out of this X store A. Let me go back to the graph here. I am going to finish out this problem just so that people that want to see the whole thing can see it. Really all you need to know is that once you've got A and B and C, you'll do an integral between A and B for this one. You'll do an integral between B and C for this one. You'll make this one positive, and you'll add the two of them together. So if that's enough for you, great. You can stop watching the video now. If you want to see the whole thing or if you want to check your answer, you can fast forward to the end. I'm going to sort of walk through the rest of the steps now. So the next step would be to find the next 0. So, and I'm going to do it quicker here. I'm going to say that the left bound seems to be 0, the right bound seems to be 1, and my guess, I don't know, I'll go a half. Great, so it comes back with that for me. So I will store that to B. And again, on my paper, I'm going to write down 0.539. For my C value, let's see, here we go, calc 2. Looks like I can go with a left bound of, and if you're not sure, you can, a left bound of 1, a right bound of 3, and a guess of 2. You really don't have to be terribly close. It'll come back and give us that value. So this time I'm doing X store to C, because I don't want to overwrite any of my previous values. So C is 1.675. Great. So now for setting up the integral of this thing, I'm going to do, let's see, the integral from A to B of my function, which was f of x dx, and let's actually check, did I call it? Yeah, since this function is called f of x in the problem, you can actually just write f of x. So now the question is, should it be plus or minus? And my answer is, we certainly want to do this area plus this area, but when I do the integral from b to c of f of x dx, this integral is naturally going to be negative because the area is under the axis. So I'm going to make that a minus so that I sort of get the answer right. So now that I've sort of got that thing set up, I can bring it back to the calculator and do that, right? I'm going to do math 9 for the integral. I've got an a and a b, and then I'll do the alpha f4 pick y1 dx, and then I'm going to do minus. Now again, we can do math 9. This one will be b to c, again alpha f4, choosing the y1 function again with respect to x. We hit enter and it thinks and thinks and comes back and tells us that this integral is 9.554. And that's how you use the calculator to find these points of intersection, to do these integrals. A lot of times these problems do come up as calculator problems, so it's important that you guys know this stuff. So I'm sure this video was longer than I wanted it to be, but I hope that it was thorough enough that it gave you guys the information you needed to get through the calculator problems. So I'll see you in class.